The practice test. We are going to have a test on Thursday. Of course, with the online nature of the class, I could make that any 2-hour session between Thursday and, say, Saturday, and just when you have time to sit down at a computer. Um, so I'll try to set it up so to give you 2 hours to do it, um, and and then have it so that you can sit down, start at any time. I'm going to go through some of the problems from the practice test. Problem 1. There are other ways of expressing an uncertainty besides significant figures. For example, suppose a quantity is known to have a value between 20.4 and 20, and our best estimate for the value is mid-range at 20.2. We could write the number as 20.2 plus or minus 0.2 and say that the number has a 1% uncertainty. We would also say it has 3 significant figures. If we square a number with 1% uncertainty and 3 significant figures, what results? I actually kind of gave a discussion of this in regards to a situation where we have 2 different variables in last lab, but this is the same variable used twice. I'm going to think about if x is 20.2 plus or minus 0.2. Wait a second, was it 20.2? Yeah. We get a minimum of 400 from 20 squared. We get a mid-range of 408.04 as the 20.2 squared, and a maximum of 416.16. So I'll make another column for delta x, the change in x squared. So for the mid-range, of course, this is going to be 0. Then for this, it's going to be about 8, and for this, it's going to be about minus 8. So it looks like our end result is going to be about 408 plus or minus 8, and 8 out of 408 is about 2%. So the answer to that problem is B, a number with 2% uncertainty and 3 significant figures. Before I go on, I want to talk a little bit about where this 8 is, where it's represented in this diagram, and it's the sum of these 2 rectangles, this one being 20.2 times 0.2, and this one being also 20.2 on this long side and 0.2 on the short edge. This is a different formula than we had when we did the lab 2. I talked about a little bit about something where we had an x equals x bar plus or minus alpha sub x, and y equals y bar plus or minus alpha sub y. And in that case, we thought of this as a rectangle being x bar across and alpha sub y tall, and this being a rectangle of alpha sub x across and y bar tall. And what we found, what was interesting there was this area and this area are independent, because there's nothing about y bar alpha sub x that is dependent on x bar and by alpha sub y. Those 2 areas are completely different. So in that case, we've got these 2, think of them as orthogonal regions, and I'm sorry, orthogonal is one way, independent is another way of saying it. And that, sorry, orthogonal or independent. And that is why we use this equation to say square root of this area squared plus this area squared, which was the square root of y bar alpha sub x squared plus x bar alpha sub y squared. Now we would get a different answer if this was 20.2 plus or minus 0.2 and this was 20.2 plus or minus 0.2. We would have got 0.2 times 20.2, and this would have been the same thing. So square root of 2 times that, which would have been equal to square root of 2, oops, sorry, this part is squared, 20.2, or square root of 2 times 0.2 times 20.2. So I took the square root of that squared, so that came out like that. This value up here, though, was not square root of 2 times 0.2 times 20.2. It was just 8 equals, well, 8 equals 2 times 0.2 times 20.2. So instead of getting a square root of 2, we got a 2. Sorry. And the reason is that we know that these two things are going to be equal in this problem. In this problem, they are not equal, and they're completely independent from each other. So it's analogous to this one being adding two lines in the same direction. And this one is like adding two lines in perpendicular to each other. So the two lines have length x bar alpha sub x and x bar alpha sub x. And this one has x bar alpha sub y and x bar or y bar alpha sub x. And so there's basically, think of it as having a 90-degree angle in between them. So you can see the x bar alpha sub x times 2 comes out to be 8.08, and if you had done it with the square root of 2 involved, it would have been 5.713. 5.713 divided by 408 is about 1.4%. So if those had been two independent values of 20.2 plus or minus 0.2, it would have been a number with a 1% uncertainty and three significant figures, specifically a 1.4% uncertainty.